Congratulations, you've implemented a fast binary search. And now we can move on to sort. In sort, you have the option of implementing a selection sort or a bubble sort. So let's look at selection sort first. In selection sort, we start by going to the beginning of the array and then following through to replace the beginning of the array with the minimum value found. How does that work? Let's go through this example. In this example, I have a short list of 5 integers. We're going to start by replacing index 0 with the minimum value that we find in this array. So, knowing that I start at 0, I'm going to put my I index there. Now, I haven't looked at any other values in this array, so for right now, let's say that this value is the minimum. So starting at index 1, I have the value 5. Then we progress to index 2, where the value 2 there is less than 3, so that becomes where the new minimum is. Progressing to index 3, we find that 1 is less than 2, so then that becomes the location of the new minimum. Going to index 4, we find that, well, 4 is greater than 1, so when we were at index 3, we actually found the minimum. So then now that we found that, we switch those two values from the beginning to where we found the minimum. So now we have an array that's definitely sorted for the very first value, but not for the remaining 4. So then we advance our I indicator for the remaining 4 in the list. We don't need to worry about that first value because we know that it's the minimum value. So then we do the same process as before, where we search the remaining 4 elements in that list for the minimum value. In this case, we find that it's at index 2. So then what we do is we switch the 2 with the 5. So now the first 2 elements of the list are sorted, and now we look at the remaining 3. For the remaining 3, we find that the minimum is, well, 3. And so we switch that with the 5 and continue that process until we have a completely sorted list. Now that we've gone through an example, let's look at what the pseudocode looks like. So for I equals 0 to n minus 2, that is from the very first element all the way to the penultimate one. That is not the last one, but the one right before that. We want to find the smallest element from I to n minus 1. From there, I exchange the smallest element with the element that I had at I. Now, by incrementing I every time, essentially what we do is we make sure that in order from the beginning all the way to the end, we find the minimum value of the array. And that way, we have an array sorted in incremental order. We've finished talking about selection sort, so let's talk about bubble sort. In bubble sort, we iterate over a list, comparing adjacent elements. Now, if those elements are in the wrong order, then we swap them. This way, the largest element will sort of bubble to the end. That's how it gets its name. And then we repeat that for the whole list until no elements have been swapped. Then we consider the list as successfully sorted. Let's take a look at an example. Here in my 5-element array, we're going to start at the beginning at index 0 and index 1. Comparing these, I see that the 3 and 5 are in fact in order. 3 is less than 5. So then I proceed to compare index 1 and 2. Now 5 and 2 are out of order, so I'm going to swap those. And then I compare 2 and 3. 5 is greater than 1, so I swap those again. And then continuing on, I swap 5 and 4. So you see how 5 started out at the second element and now is at the end, being the largest element in the list. Now that 5's bubbled through, I go back to the beginning of my list. I look at indices 0 and 1 and find that 3 is out of order because it's greater than 2. So I swap those and then continue on. 3 then bubbles through to element 2, but find that when we advance to comparing 3 and 4, those are actually in order. So the 3 bubbled its way, but not all the way to the end. Now that 5's bubbled its way to the end of the list, we go back to the beginning again. So we compare indices 0 and 1 and find that 3 is larger than 2. It's out of order, so we swap those. Then proceeding on, we compare 3 and 1, and 3 is larger than 1, so we swap that again. So far, 3's bubbled its way from the beginning all the way to the middle of the list. But 3 isn't greater than 4, so we actually don't swap those. We don't need to make one last comparison because 5 already bubbled its way to the end of the list in the first iteration, so we can just go to the beginning again. We look at index 0 and index 1 and we swap 2 and 1 and then proceed, and we don't need to swap 2 and 3, so then 3 is set. Then comparing 1 and 2, no swaps need to be made, so then that means that we've finished sorting our list. That was bubble sort, and we already talked about selection sort, so there you have it. Now you can sort an array and do a binary search on it. My name is Zamila. and this was find.